Okay, so here we go. Sine Law, Part 1, Section 3.5. Now, in the last section, we looked at solving oblique triangles by breaking them down into right angle triangles using SOHCAHTOA and Pythagoras. The sine law, or what they call the law of sines, is used to solve oblique triangles without breaking them down into right angle triangles. So this is one method to solve oblique triangles. And what we need to look for, in my opinion, is what I like to call angle side pairs. Now, angle side pairs, we need to understand how we name a triangle first of all. So here we have a triangle, angle A, angle B, angle C. Okay, now each angle has an associated side, which makes up the angle side pair. And the side opposite angle A is called little a. The side opposite angle B is called little b, and the side opposite angle C is called little c. That's incredibly important to grasp in order to be able to use this sine law stuff, okay? So here we go. Here are the two versions of the sine law that I'm going to give to you, and they both involve pairs of angle side, angle side, angle side. This one has the sides on the top, and I use this one when I'm looking for sides because I find that the algebra is a little bit easier if the unknown that you're looking for is on top. So if you're looking for the angle, then I would choose to use this one because my unknown would be in the numerator. Okay, so in the bottom one here, it's when I'm looking for angles, and the top one here is when I'm looking for sides. Now notice that you have three ratios here, okay? We only really use two at a time. So you're either comparing A and B together, you're comparing B and C together, or you're comparing A and C, right? We never use all three at the same time. So let's look at a couple examples here. Here is one where we're given triangle ABC and an angle, two angles and a side. So I hope you remember from the last lesson how I talked about always creating a baseline as a reference, okay? Now I've got an angle B, which is 29 degrees. We can draw that up here like this, call that 29 degrees. This is angle B, okay? Angle C, 105. We can draw it down here if you want, call that 105. I like to call, I don't know, we can do it either way. I'm going to call this one 105. Call that angle C. And side B is 3, okay? So what we're looking for is the size of angle A, and the size of side A, and the size of side C. One of those is super easy to find right away, hoping that you can see that it's angle A, since angle A is equal to 180, right? 180 minus these other two sides, okay? So it's 46 degrees. So let's just put that in there, make it easier to see the diagram. So we've got 46 degrees, okay? Now, always in these questions, look for the pair that you have. And I'm hoping that you see that I have that pair right there. I have side B and angle B. So side B and angle B. I'm looking for side A and angle A. Let's start with side A. So side A, since that's what I'm looking for, I'm going to put that on the top. So A, I don't know it, sine A. Well, sine A, angle A is 46 degrees, right? And let's use the one we have now. So side B, which is 3, right? Side B over sine B. And the associated angle is 29 degrees. So what we've done is created a proportion here with the unknown on the top. So the math on your calculator here, give it a shot, see if you can come up with an answer. Okay, pause it, give it a quick try. I'll show you how I do it. So I always take the one that I have. So 3 divided by sine 29, I get an answer. And whenever I create it this way with the unknown at the top, this always gets multiplied by this side. So now I just go times sine 46, and I end up with A equaling 4.45. So here I have side A is 4.45. Okay, so side A, 4.45. Now, I'm looking for side C here. There is another pair. All right, so I'm looking for side C, so let's start with side C. Side C, right, over sine C, sine 105. So side C over side C. Let's use the ratio that was given at the beginning of the question, or in the question, because it's a little more accurate. We rounded this number off. So if we use that in this calculation, it would make our answer a little bit more off, but it would be close enough, I would think. But it's a good practice to use the information that you're given in these questions. It means that your answer is going to be a little more accurate, okay? So here we go. Same sort of situation. So 3 divided by sine 29, right, times sine 105. And I get 5.97. Or do we just round that off to 6? Okay, so C is 6.0, we'll call it. And we found all the pieces of this triangle now. So, and that's 6. We solved it. Boom, boom. Now, I think there's another question here. Let's have a look. A little bit different, but doable nonetheless. You have an option when you draw these triangles, folks. You can draw them however you like, okay? I'm giving you suggestions. If you do it a different way and you're happy with that and it works, then be my guest. So I'm going to start with my baseline all the time. The angle I'm given, I'll put down the bottom left corner. I'll put 41 degrees here. I'll label it G right away. Now, if I'm giving a side, look, side G, angle G. So G is over here somewhere, right? H is 15. I'm going to call that one up here. I like to call my angled line up there 15. That means that G down here, we're going to have to call that 12 here. Okay. That means if this is side H, that's angle H. That leaves me angle F up there. Now, what we're looking for is side F, angle H, and angle F, right? So 3 pieces that we're looking for. Now, let's look at the information we have and find that pair first. So you can see that this G pair is what I have. I have another piece of information here, which is side H. So this is the other pair that I'm going to have to use. Looking for angle H, so I start off by going sine H over 15 is equal to sine 41 over 12, right? Sine G over side G. And now we've got the unknown on the top again, and we do the same thing. We do the division of the known ratio that you have. So sine 41 divided by 12 is 0.05. Now we multiply it by 15. And let me just show you this last step. So sine H is equal to 0.820073. If you want to find H, you go second sine. And I'll just put that answer back in there. And it gives me angle H as being 55.1 degrees. Okay, let's just round it to 55 degrees. So here we go. We'll call that 55 degrees. Now I have 2 of the 3 angles. So if I manage to say 180 minus 55 minus 41, and I get 84 degrees. So angle F now is 84 degrees. Let's call that 51. And I'm looking for side F now. So this one we'll call 84 degrees. I'm looking for side F. There's another pair. Looking for side F. Start with F over sine F. 84 degrees is equal to, let's use the ratio that we're given at the beginning, 12 over sine 41. And again with the math here, right, 12 divided by sine 41 times it by sine 84, and you get 18.2. So this is 18.2, and side F is 18.2. 2 different types of questions that you're going to get with the sine law. The next one deals with what we call the ambiguous case. Thanks very much. Oh, yep, they're all good.